Hello there, I hope you're doing well. Now, today I want us to talk about a given specific electrical component, that is a resistor. If someone asks you, what is a resistor? This is just an electrical component that regulates or limits the flow of current in a given electrical circuit. Now, there are different types of resistors in IGCSE curriculum and even 844. We have fixed resistor, variable resistor, diodes, thermistors, LDR, and you can name them. Now, I have made some videos which you can able to find in the link above there about a diode and about a thermistor. Today, I want us to focus mainly on a fixed resistor. Now, what you're going to find out from video is this. Number one, we're going to look at how a fixed resistor affects the current flow by doing it. Number two, we are going to find out if resistors are connected in series, how do we find their combined resistance? By experiment. What if they are connected in parallel? How do we find their combined resistance? Probably you've learned about this, but it is time for practical. It is time to find it out if we have been using the right method. So this is the circuit we are going to use. So here is a switch, open switch, an ammeter, which is here, a battery, which is here, and then we have a bulb, and that is all here. So we need to investigate. We're going to record the current that is flowing when there is no resistor, and then we also observe the brightness of the bulb without the resistor. So record or observe the brightness of the bulb. When an ammeter is giving you a negative value, all you need to do is just to change the terminals. So you can able to see there is a positive value, which is 0.26 amps. So when I look at the effect of a resistor on the brightness of the bulb, then we're going to use the same circuit, but then now what we do is just to, so there is a switch, we have an ammeter to record the current, we still have the cell, battery, then here we can have our resistor. I have a fixed resistor. The resistor we're talking about is a fixed resistor. Later on we're going to find out how to find its resistance. So from here we will have a bulb because we want to see its effect on the brightness. So there we go. So let's start. So according to our circuit, we need to add the resistor from the bulb to the battery. So circuit is complete. So let's put it on. So you can able to see, notice, let me put the light on. You can able to notice the brightness of the bulb as compared to the initial one. You can able to see the difference, that the brightness has decreased, and so does the current flowing. Let's see the value of current that is flowing. The value of current current that is flowing is 0.20. We know that R is given by V over I, where R is the resistance of the resistor, while I is the current that is flowing, which already noted here. This is Ohm's law. So what we are going to need, we're going to need a voltmeter which will be connected across the resistor. You can put the voltmeter this side, but there is no difference as long as it is across the resistor. So what we need to do is to put our circuit. So the voltage is 0.46, while the current is 0.20. 0.20. That's the current. The voltage is 0.46. So from here, V is 0.46 volts, while current we already found to be 0.20 amps. From our calculation. From the manufacturer, the resistance of this resistor is 2.2 ohms. What we have got is 2.3 ohms. Now remember, every time we are taking measurement or doing experiment, there is always that uncertainty which should always be calculated. So from here we can able to find the uncertainty due to the measurement that we have taken and the calculations. Let's to investigate the resistors in series. So we are going to use two resistors here. That is R1, R2. I have a bulb here that will, by observation, of course the ammeter also will be here just to record the current. So the bulb is just to, you just want to see the brightness, apart from reading what we'll be able to have here. Though in this case here they are all doing the same work, though this bulb, it also has resistance, but then we want to focus on R1 and R2. So the first thing to do is to check if the connection is correct before we switch on. After confirming that the circuit is correct, then we can able to put on. So we close the switch, and when we close the switch, so we can able to observe there is current which is 0.19, but then there is, so let's observe the brightness of the bulb is too low. Let's try to say this. So the bulb is lighting there, yes, you can able to see, but it's too dim. So current that is flowing, current I that is flowing is 0.19 amps. What I want to do, I want to connect voltmeter across R1 and R2 combined. So you find the voltage across them. So they're going to behave like one resistor. Then we see what will be the resistance of R1 and R2. This is the voltmeter. It's here. We'll connect this side. The circuit is still complete. So there we go. So the voltage is 0.82 while current is 0.19. So that is so voltage V, that is 0.82 volts. Then you can switch them off. Put off. So from here we know that resistance. So from Ohm's law, we know that V is equal to IR. This implies that R is given by V divided by I. V is 0.82 volts divided by 0.19 amps. So 0.82 divided by 0.19, this gives us 4.32 ohms. 4.32 ohms. Now from the manufacturer, the resistance of R1 is supposed to be 2.2 ohms. Resistance of this R2 is also 2.2 ohms. You can able to see clearly this value. If you add this and this, it will give you 4.4, but then from the experiment what we have gotten is 4.3 ohms. You can see that the difference between these values, the manufacturer and this is like the standard value now. So the standard value and the measured value, the difference is within the limit of experimental accuracy, and therefore when resistors are in series, then what you need to do is just to add to find the total or the effective resistance. So to find the effective resistance or the combined resistance when they're in series, you just need to add. That is what the experimenters proved to us. Look at the effect of resistors when connected in parallel to the electric current and the brightness of the bulb. At this junction here, what I want us to do is now to connect these resistors in parallel. So let's start. So in parallel, that means we're supposed to be having something like this. Remember, in series, this to this, but then in parallel, we can just make a junction here like this. Now we have resistors in parallel. So we do the usual. The circuit is already in order, that was confirmed. So what I want to do is now to put it on and observe what happens. Let's put this one on. So the current is 0.22. The brightness of the bulb we can able to notice. Compare with the previous one. So that's the current. So the current is 0.22. Let's have a voltmeter connected across the combined resistors. voltmeter is showing a reading of 0.24. The current is 0.22. So let's do that calculation. So this is R1, R2 from here, 1, 2. So the voltage is 0.24 volts. Then current I, that was 0.22 amps, 0.22 amps. So therefore the resistance here R, that is V over I, that gives us 0.24 volts divided by 0.222 amps. So this should give us so that is 1.09, which is approximately equal to 1.1 ohms. Now remember, from the theoretical value of this resistance, so resistor 1 is actually 2.2 ohms, resistor 2 is 2.2 ohms. When they are combined together, you are saying that when they are in series, when they're in parallel, the combined resistance is 1.1 ohm. So it therefore means that when resistors are combined in parallel, the effective resistance is less compared to the individual values. Look at this. If this 2.2 and is almost half of it, so this reminds you that effective resistance, that is 1 over Re, is given by 1 over R1 plus 1 over R2. So if we're supposed to work out this, that will be 1 over 2.2 plus 1 over 2.2, which this will give us 2.2 times 2.2 over 2. So from here we will have, let me just use a calculator. So that is 1 divided by 2.2, I multiply by 2, then I find the reciprocal. So the reciprocal of the answer that is 1.1. So indeed this shows us that this is the right formula to use to find the effective resistance when they are connected in parallel. So that is 1.1 ohms, which is almost the same as this. Now, from the experiment that we have carried out and calculation that we have done, we can therefore conclude, we can make the following observation. Now, when we have a fixed resistor, one single fixed resistor of a resistance of 2.2 ohms, the effective resistance will be, so the effective resistance will be 2.2 ohms because it is just a single resistor. If there are two resistors in series, then the effective or combined resistance will be 2 plus 2, 2.2 plus 2.2, which will give us 4.4 ohms. When the resistors are in parallel, the combined resistance, which is given by product, so that is 2.2 times 2.2 over the sum 2.2, this will give us 1.1 ohms. Now look at this. When resistors are in series, the total or effective resistance is very high compared to when you're having a single resistance, and then when resistors are in series, then the effective resistance is very low, less than that of a single resistance. This is not but just one of the advantages of connecting electrical components in parallel. Thank you for watching, and kindly subscribe. Watch out for the next videos where we'll be able to solve questions relating to resistors. Have a nice time. Take care. Bye.